Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello and welcome to today's episode. I hope you're well. Today we'll be talking about balancing chemical equations. And so we need to start with understanding what is a chemical equation, what's it used for, how and why do we balance it. We'll talk about three different types of chemical equation as well. So what is a chemical equation? It's a way of showing the reactants and the products in a reaction and also their ratios, the ratios in which the reactants react and the products form in relation to the reactants too. We write them left to right, of course, and on the left we have the formula of all the reactants. Then we have an arrow pointed towards the right, and to the right of that we write the formula of all the products. I'm sure you've seen and even written some chemical equations, and you know that you'll sometimes see or use numbers in front of a particular formula or more than one formula, and that shows the ratio in which the reactants react or the products form. That number in front of a formula is known as the coefficient, and that coefficient is the ratio of molecules reacting with each other or being formed, but also more importantly, the ratio of moles that react or form. So how do you write an equation? Well, you can start with a word equation if you like, and on the left you would write the names of the reactions, then the arrow pointing to the right, and then the names of the products after the arrow. When you've done that, replace the names that are written in words with the correct chemical formula for each of the reactants or products. And this is really important. I call this the golden rule of writing and balancing equations. That rule is that for each of the reactants or products, you must use the correct formula. It must be correct. If you don't use the correct formula, it won't make sense, and your calculations based on it are bound to be wrong. That might all seem obvious, but I have seen a number of students try to adjust the formula to be more convenient to balancing an equation, and it just doesn't work like that. Each compound has a formula. The formula is the formula, and that formula is either convenient or it's not, but it is the formula, and that's what you must use. Now you've got the correct formulas for each of the reactants and products. We need to show the ratio they react or are produced, and we do that by writing a coefficient in front of each formula. Actually, you don't need to write the coefficient when it's 1, but where the coefficient for one of the reactants or products is something different from 1, you must write that number in front of that formula. Okay, so now we have the correct formulas and we have the coefficients showing the ratios of reaction. It's really good practice. It's often expected that you write the state symbols for each of the reactants and products too. So how do we do this? So immediately after each formula and as a subscript, we write S or L or G or AQ in a bracket. And that's S for solid if the substance is solid in that reaction, L for liquid if it's a liquid we're using in the reaction, G for gas if it's a gas, and AQ for aqueous, meaning that that substance, that species, is dissolved in the water if water is being used as a solvent for that reaction. Now we have the full balanced chemical equation. What do we use it for? Why do we need it? So in short, it's a universal way of describing a reaction in detail. It's using formula so that that's understood no matter what language. We have the ratios so that that is defined too. We now have the state that each substance is in. What can we use it for? We can use it in calculations, for example, calculating the amount of product formed or expected, or the amount of reactant required. So far we've talked about the full chemical equation, but there are two others we need to talk about too. Firstly, an ionic equation. An ionic equation shows just the ions that are reacting, and we leave out those that aren't reacting, they're not changing in the reaction. You may have heard those non-reacting ions described as spectator ions. Let's think of an example. In a simple reaction between sodium hydroxide and hydrochloric acid, we should recognise that the sodium ion and the chloride ion aren't changing, they just remain as aqueous ions, and they are spectator ions, so we can leave them out of an ionic equation. However, the aqueous H plus ion and the aqueous hydroxide ion do react with each other and they become water molecules. So our ionic equation for this reaction would only show the H plus, the OH minus, and the product of water. So our equation would be H plus with an AQ plus OH minus, AQ, and then our right pointing arrow, and then H2O and L. Water is a liquid product, even though there's plenty of other water there. The product is liquid, it's not dissolved in water, so we use L. The other type of equation we need to consider is half equations. And these are used to describe what's going on in redox reactions. We can write a half equation for the oxidation that is going on, so that includes all the species involved in the oxidation. And we can write a separate half equation for what's happening with the reductions, all the species involved in the reduction. So for each redox reaction, we can write two half equations, one for the oxidation, one for the reduction, and that's why they are half equations. They're showing that half of what is happening. The oxidation half equation will include one or more electrons on the product side. A reduction half equation will include one or more electrons on the reactant side. Okay, so that's the three different types of chemical equation we need to consider. The full equation with all the substances in full, ionic equation that leaves out spectator ions, and our half equations related to redox reactions. We've talked about how to balance them, and there's some rules that we need to consider when balancing them. We use those rules when we're doing the balancing, and we can use them to check that we've done it correctly. In all three types of equation, we need to make sure that all the atoms of each element on the reactant side and all the atoms of each element on the product side are balanced. For example, if there happen to be 6 hydrogens on the reactant side, there also has to be 6 hydrogens on the product side. Atoms neither get created or lost during a reaction. The other thing that needs to be balanced is the total charge on the reactant side and the total charge on the product side. Now, with a full chemical reaction, there shouldn't be any charges anyway. We're dealing with neutral compounds. For ionic equations, obviously ions have charge, so you need to ensure that all charges on the reactant side equals the same as all the charges on the product side. And if you're checking through and that's not correct, have a look to see where the error is. Go back and check your adding, but also check that everything that you've written there should be there and that you haven't missed something. As an example to show balancing of the charge, we talked about the ionic equation where H plus and OH minus reacted together and gave the product of water. So we have one H plus and one OH minus on the reactant side. So there's one positive and one negative charge, so the reactant side is neutral. On the product side, we only have water. Water is neutral, so both sides have the same charge. They happen to be neutral in this case, but they have the same charge, and that's the important thing. Now, when it comes to half equations, there is one thing that doesn't have to balance. You will have electrons on either the reactant side or the product side, depending on whether it's a reduction or an oxidation half equation. You won't have electrons on both sides, and if you have, there's a problem. And of course, because you can't have electrons on both the reactant and the product side of the same half equation, it follows that you don't need to balance the electrons. In fact, they won't balance. You will have some on one side and none on the other if you've done it correctly. Okay, time to summarize what we've talked about today. We've talked about what chemical equations are and 3 different types. So we talked about a full chemical equation, which includes the full formula for each of the reactants and products. We talked about ionic equations, where we leave out the spectator ions and only include the ions that react and the products formed from those. And we talked about half equations, which described the oxidation or the reduction within a redox reaction. We talked about why we use chemical equations, because they're a universal way to describe the reaction, the ratio of reactants and products, and we even include the state symbols to show the state in which each reactant or product is expected. We talked about balancing equations and the fact that in all those types we must have the same number of atoms of each element in the reactants, also in the products. Or the numbers just don't balance, the equation is not balanced. We also said that balancing means that the total charge on the reactant side and the total charge on the product side must balance as well. If they don't, there is an issue with that. And we said that the only thing that doesn't need to balance and actually mustn't balance is the number of electrons that are either in the reactant or the product side of a half equation, because the electrons must only be on the reactant or the product side in a half equation. The total charge for each side still needs to balance when we include the charges of those electrons. We also said that not balancing equations, firstly, doesn't describe what's going on in the reaction correctly. And most importantly, using an unbalanced or incorrectly balanced chemical equation will mean that any calculations you do based on it will not be correct. So it really is important to make sure you know how to balance equations, how to understand balanced equations. We also mentioned the golden rule. Always use the correct formula for all the substances within your chemical equation. You won't balance correctly and you won't be able to do correct calculations unless you do that. That brings us to the end of this episode about chemical equations and balancing them. I hope it's been useful to you. If you still have questions on this, then please feel free to comment below if you're on a platform where you can put comments. You can also ask questions by DMing me on Instagram, and that's at Chemistry Made Simple. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistrymadesimple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself and goodbye.